Number 1, select all of the quadratic expressions in vertex form. So vertex form looks like this, where we've got, and I'm going to add some stuff in here in a second. So let me get this outlined. Where we've got possibly a number out front multiplied by our expression. We also might have a number on the inside. So x minus, and this could be plus or minus in here. And then we've got a number outside here, okay, potentially. It doesn't have to be there. So A, H, and K are just real numbers, okay? They're not variables, so they're not going to have an X with them. They're just any number, and that number includes 0, so it doesn't have to be here, or this A could be a 1, okay? So you don't have to see all of them for it to be in vertex form. So part A, in vertex form. Okay, it's got the thing squared, something inside and outside. This is fine. It's in vertex form. B is also in vertex form. It just doesn't have an H value. Okay, so on the inside, if we wanted to write it like this, we could. It would be 1 times x minus 0 squared minus 4. So then when we simplified, it just looks like this. So B is in vertex form. C is not, because this number out front cannot be a variable, and we need a squared here. So this is not. This is in factored form. D is good. Okay, so D has something, you know, your little x plus 3 squared. So really it's 1 times x plus 3 squared plus 0. That's fine. And E, also in vertex form. Okay, has that H and K value that you can see. Number 2, here are 2 equations. One defines function M, the other defines function P, so we can see this. It says, show that the expressions defining M and P are equivalent. So we're going to just multiply out both functions so that we can see them in standard form. So if we multiply, if we distribute this x in, so we're going to do x times x and x times 6. So we find out that m of x is equal to x squared plus 6x when it's expanded. P of x, we're going to do the same thing. So first off, we're going to multiply this x plus 3 squared. And so you can do that different ways, but remember it's x plus 3 times x plus 3. So you can either distribute the x to both pieces and the 3. You can also do the area model where you have the x and 3 on the side and the x and 3 on the top. So x times x is x squared, x times 3 is 3x, x times 3 is 3x, and 3 times 3 is 9. And then we see that we have like terms here. So we're going to end up adding those together. So for P of x, so far for this part, we have x squared, 2 3x's, which is 6x, and this plus 9. And then don't forget about this minus 9 here. And then we see that we have like terms here of a positive and a negative 9. So we'll add those together and they equal 0. So we really just have x squared plus 6x, which shows that these are equivalent. They have the exact same terms in standard form. Part B says, what is the vertex of graph M? So if these are equivalent graphs, okay, and so the vertex, we can actually find the vertex from P, and we know it's going to be the same as M because these are equivalent. So if we look at the vertex here, it's going to be the opposite of this number for your x coordinate. So instead of positive 3, it's going to be negative 3. And then this one is exactly the same. And so that's negative 9, because in vertex form, okay, it says x minus h, meaning x with the opposite of the x coordinate. And then it says plus k, which means that this is exactly what it looks like, okay? Because it just says add on the k term, so you'll see the k term. So this is the vertex. Then it says, what are the x-intercepts of the graph of P? So again, if these are equivalent, we can use the factored form from M to get us our x-intercepts. So we know that 0 will make that first part 0. So x equals 0 is an x-intercept. And -6 will make this second factor 0. So -6 is our other x-intercept. And that will be the same for graph P because they are equivalent. Number 3, which equation is represented by this graph? So again, we have the vertex. All of these are in vertex form. So remember that vertex form looks like this: x minus the x coordinate squared, and then plus the y coordinate. So your x coordinate, we just call it an h often, and then we call the y coordinate a k. But so you want to look, this means your x is going to be the opposite. Okay, so the opposite of what the actual coordinate is, and then the k is going to be the exact same thing. So when we look here, okay, we have a -3 for the x coordinate. So when we put it in here, it's going to say x plus 3, because what's going to happen is you're going to go minus a -3. So minus a negative is plus, and then we are going to add the y coordinate on the outside, and our y coordinate of our vertex here is -1. So if we simplify that, it'd just be x plus 3 squared, and then you don't have to say plus a negative. You could just say -1. So when we look, we're going to have a +3 and a -1. And then this negative out front is because it's upside down. So our parabola is upside down, so it flipped over. So that's going to be a negative out front to flip it. Number 4, for each equation, write the coordinates of the vertex of the graph that represents the equation. Okay, so again, you're looking for the opposite of your x coordinate and the same thing that's out there as your y coordinate. Okay, so when we write this, and let me just get these, I'm just gonna put these for each thing so that I can write it out quicker. All right, so when we look at this for the x coordinate, so the opposite of -3 is +3, so that's what we're gonna want. And then our y coordinate is just this number at 5. For the second one, the opposite of +7 is -7. And then we want to keep this outside number the exact same as our y value. For C, the opposite of -4 is +4. And then we don't have anything outside of here, so that's really a +0. So the y coordinate is going to be 0. For D, we don't have anything in with the x, right? So that's going to be a 0. And then our y coordinate, we see a -1 on the outside, so our y coordinate is going to be -1. For part E, the opposite of +1 is -1. And then we have the -5 outside would be our y value. For part F, the opposite of +1 is -1. And then we have a -5 out front. So that's going to be -5. So none of the stuff, the a value or the number in front of the parentheses, doesn't impact the vertex. That's going to just change the direction possibly of your parabola if it's negative, and then it's going to change the width of it. Number 5, for each function, write down the coordinates of the vertex and tell whether the graph opens upward or downward. All right, so for our vertex, again, we're going to have the x is going to be the opposite of what's inside your parentheses squared. So we've got that -4. So this is going to be 4. And then the y coordinate is the same as this, so -5. Then for opening up or down, it depends on if this number out here is positive or negative. So right now in this one, okay, and for multiplication, if it's not written, it's just a 1. So it's 1 times this, and that's positive. So this is going to open upward. For g of x, okay, we have nothing inside the parenthesis here. So our x coordinate of our vertex is 0. And then we have a +5. So our y coordinate is going to be 5. And then we have this negative out front of the x squared. So this means that we're going to have our parabola flipped over or reflected over the x-axis. So then that one's going to be opening downward. H of x, so we've got a +1 here. Opposite of that is -1. Then we've got this y coordinate of -4. And then the number out front here is a +2. So then this is going to open upward. Number 6 here is a graph that represents y equals x squared. Describe what would happen to the graph if the original equation were modified as follows. So in this case, we have a negative x squared instead. So this is just going to reflect it over the x-axis, which what that means is it's just going to open downward. Okay, so it's just going to open downward like that. Then we have a 3 out front this time. So that's 3 times this. So this is just going to stretch your graph. And really, if we want to get a little bit more technical, it's going to be a vertical stretch. So it's just going to grab these branches and stretch them upward by a factor of 3. And what that's going to look like is this is going to get narrower or skinnier. Okay, so it's going to make it look skinnier. And then this +6 here is going to translate the graph up 6 units. So really like it's going to move it up 6, right? So it's going to move it up 6. So then it says actually do this. So sketch the equation of all of these together. And so you can do them each separately. This is the order that you would do it in, but then they want you to overall get this whole thing together. So it needs to be flipped over, it needs to be skinnier, and it needs to be moved up 6 units. So it's going to go up here, it's going to be flipped over, okay, and it's going to be skinnier than the original one was. So something like that. Number 7, Noah is going to put $2,000 into a savings account. He plans on putting the money in an account and leaving it there for 5 years. He can put money into an account that pays 1% monthly, or an account that pays 6% every 6 months, or an account that pays 12% annually. Which account will give him the most money in his account at the end of 4 years? So these are the things that are changing. So 1% monthly is going to be one of these. Then we've got the 6% every 6 months, and we've got 12% annually. So let's write out the different equations for this. So a couple of things that stay the same is the amount of money that he's investing. Okay, so he's got 2,000, and then he's going to multiply this by the growth factor. And he's going to put this in for 5 years. And remember, this growth factor is going to be the interest rate plus as a decimal plus 1. Okay. Or we can think of it as writing 100% plus the interest rate. But in this case, we're going to want to do the 1 plus the interest rate divided by the number of times it's compounding, because it's changing. It's not just annual. So in this one, we have 1% monthly. So 1% as a decimal is 0.01. We are calculating this monthly. Oh, we don't need to divide. So this is the monthly interest rate. So this one's going to go in here. So just 1% monthly. But now every month for 5 years, Noah's going to get this paid. So we have 5 years, and then there's 12 months per year. So you want to multiply this number of times he's going to get paid by 12, because there's 5 years, 12 months per year. And then we'll calculate that in a minute. So then the next account, he's again putting 2,000 in, okay, and he's putting it in for 5 years, and then this time it's paying him 6%. Okay, each time they give him a payment, but this is happening every 6 months. So how often is there 6 months each year? So this is 2 times per year versus monthly is 12 times per year. So each of the 5 years, this is happening twice. So we would multiply that exponent by 2. Then the final account is giving him 12% compounded the interest annually. So now 12% as a decimal is 0.12. And then this is just happening once per year. So this is just going to stay at 5. You can put the times 1 up there if you want, just so you can kind of see where it's coming from. So then if we calculate out each of these, so just type this in your calculator, you end up with $3,633.39 for this one. We get $3,581.70 for this one. And we get $3,524.68 for this one. So this first account is giving him more money. So getting 1% each month is better than the other options. Number 8, here are 4 graphs. Match each graph with the quadratic equation that it represents. So number 1, we see that this will make it be upside down. And there's only one graph that's upside down. So that must mean that graph C is number 1. We also see that it's going to start at 3. So it's going to be at 3 and upside down. So that matches. Number 2 is written in intercept form. And so we know that a -1 will make this 0 and a -3 will make this 0. So those are our x-intercepts. So we'll look for the graph that crosses at -1 and -3. And that is graph B for equation number 2. Number 3 is in vertex form. It's just being moved down to -3. And then we see this is positive, so it's opening upward. So this one is going to have a y-intercept at -3, and that is graph D, which leaves graph A to be number 4. And we can just make sure. So 1 would make this 0, 3 would make this 0. So our x-intercepts would be at 1 and 3, which checks out. Number 9 shows a table of some input and output values of function f. Describe a possible rule for the function using words or by writing an equation. So you want to see if you can notice a pattern here. And so it doesn't look super obvious because this is going to be from -3 to 8 is going to be -5. Well, 0 to -2 is not -5 and 4 to 6 is not. We're not just taking this times a number, right? Because -3 times something doesn't equal -8. I mean, a decimal, but not a nice number. And same for this. 4 times something doesn't equal out. So then you got to try and get a little bit creative and see if you can come up with something. So maybe we're trying to like square the number. So if we do 4 squared, that's 16. Then minus 10 would equal 6. So we could try that for another one. But 10 squared is 100. So if we minus 10 from that, that's 90. So that doesn't check out with the 18. So that's not working. We could try maybe taking it times 2. So 4 times 2 is 8. And then to get to 6 would be minusing 2. So what we did here was multiplied by 2 and then subtracted 2. So then we could try that with another one. So 10 times 2 is 20. And then we could minus 2 from that, and that gives us 18. So that worked. So then we can try it with these other ones. So 0 times 2 is 0. And then if we subtract 2 again, then we end up with negative 2, which worked out. So we can try it with negative 3. So negative 3 times 2 gives us negative 6. And then negative 6 minus 2 gives us negative 8, which is what we have here. So you can write that out in words, it says. So we could just say we need to multiply x by 2, then subtract 2. Or you can write an equation. So the equation version of that would be that we're taking our x and multiplying it by 2, then we're going to subtract 2. So we could say that our f of x is equal to 2 times the x value and then minus 2. So either of those is good.